Hello students, welcome to the class. So in the previous class, we have discussed regarding rules for assigning oxidation number. We have seen all these rules. Element in its elementary form, it is 0. Single monoatomic ion, it is oxidation state is nothing but the charge carried on the ion. Oxygen, it is having always -2. Exception says in peroxides, it is -1. If oxygen is combining with a halogen, that is fluorine especially, the oxidation state of oxygen will be +2. Yes, and in O2F2, it depends. We'll go on finding the oxidation state. Okay. Next, in non-metallic compounds, oxidation state of hydrogen will be +1. Whereas if it is metal hydrides, if hydrogen has combined with metals, then oxidation state of hydrogen will be -1. In compounds of metals and non-metals, non-metal will have negative oxidation state, whereas metal will have positive oxidation state. Yes, so all these rules we have seen. So you can see here in a carbonate, CO3 -2, sum of carbon atoms and 3 oxygen atoms should be equal to -2. That means in case of neutral molecule, the sum of the oxidation states of all the atoms should be equal to 0. If it is anion, it should be equal to the charge carried by the ion. If it is cation, it should be equal to the charge carried by that cation. So in disproportion reaction, an element in one oxidation state is simultaneously oxidized and reduced. We'll come to this reaction. Before that, for calculation, what is the procedure for calculation of oxidation number? Okay, first we will see the rules. Then we will see the exceptional cases in these 3 types of molecules. Yes, so what are the rules for calculating the oxidation number? Okay, fine. So let us begin. So the rules for calculating oxidation number. Yes. First one, by applying all the things what we have discussed in our previous video, we can calculate the oxidation number of the elements in the molecules, or it might be ions. So what are the steps? The first thing is write down the formula of the molecule. Write down the formula of the given molecule or ion, leaving some spaces in between. Yes, I'll just tell you why. Second thing what we are going to do is write the oxidation number on the top of each atom. Oxidation number should be written on top of each atom. Each atom. Write the oxidation number. Third thing is, when you have written the formula, beneath the formula, write down total oxidation number of that molecule. Total oxidation number of molecule. Okay. Fourth point, yes, so for this, how to write total oxidation number? See, when you are writing total oxidation numbers of each elements, multiply the oxidation number with the number of atoms. So if there is only one atom, what is the oxidation state? Into 1. If there are 2 atoms, oxidation state into 2. And go on doing summation of it. Equate. Next step is equate the sum of oxidation number to 0. When you will equate it to 0, if the molecule is neutral molecule. If the molecule is neutral molecule, you will equate the sum to 0, or you will equate it to the charge carried by polyatomic ion. Charge carried by the polyatomic ion. If it is -2, you'll equate it to -2. If it is +1, you'll equate it to +1. And the oxidation state of which element or atom you're finding, you solve that for X. Yes. Suppose you want to solve oxidation state of some atom, you will first, when you write the formula, the oxidation state of which element you want to find, you will write it as X. Yes. And solve for X. Last step is solve for X. Yes, so this is how we find the oxidation states of the elements. Yes, let me take examples to make this clear. Okay. So for this, we need to be knowing the rules of certain rules what we have discussed in our previous class. Okay. So let me consider the example. Let us start with examples. Okay, fine. So first example, I will take simple one. I will take H2O. Okay, so I know that when I want to, let me say I want to find the oxidation state of oxygen here. Now see, I know that, so I will keep oxidation state of oxygen as X. Yes, so we know here that when hydrogen is bonded to a non-metal, then the oxidation state of hydrogen, so this I'm going to keep X, the oxidation state of hydrogen will be +1, correct? So solve it out. So how do we solve it? H2O +1 into how many atoms of hydrogen? 2. Plus oxygen, it is taken X into how many atoms of oxygen? 1, equal to, since it is a neutral molecule, equate it to 0 as our rule says. So 2 plus X is equal to 0. So what will be X equal to? X will be equal to -2. So oxygen will carry what charge? It will carry -2 charge. Similarly, take for H2S. H2S. Okay, I want to find the oxidation state of S. So I will keep it as X. And here, what is hydrogen? Since it is bonded to a non-metal, it is +1. So solve it out. So how do we solve? +1 into 2 atoms plus X into 1, correct? So how much it is equated to 0. So again, 2 plus X, therefore X will be equal to what? -2. So oxidation state of sulfur is what? It is -2. Getting my point? This is how we solve. Let us take one more example. Oxidation state of sulfur in H2SO4. I want to find oxidation state. I will underline that molecule. We are going to find the oxidation state. So I will keep it as X. Now see, generally we know that the oxidation state of hydrogen is what? Always +1. So it is bonded to non-metals. Okay. Sulfur is taken as X. Oxygen is always -2. These are the rules which you should be knowing. Then only you will be able to solve it. Okay. So let us solve. So it is +1 into how many atoms of hydrogen? 2. Plus sulfur is X into 1. Plus oxygen is -2 into how many atoms? 4. That is equal to 0 because entire molecule is neutral. So 2 plus X -8 because -2 into 4 is -8. So X -8 plus 2 is what? -6 is equal to 0, correct? So X will be equal to what? X will be equal to 4. Sorry, X will be equal to +6. X will be equal to +6. Is that right? H2SO4. So sulfur is +6. If I give you the same molecule, H2SO, instead of 4, I will give you 3. So can we work it out on it? So sulfur, underline, you want to find it for sulfur. So it is X. Okay. So let us solve it out. Hydrogen +1 into 2 plus sulfur X into 1 plus oxygen is -2 into 3 is equal to 0. So 1 2s are 2 plus X -6 is equal to 0. So X will be equal to what? -4, that is equal to +4. So here it is +4. Getting my point? So this is how we find the oxidation state. Few more examples. Okay, let me say I want to find oxidation state of nitrogen here. Okay, so the compound what I will take is, I will take NH3. First, let us consider simple. It is what? It is a neutral molecule. I want to find for nitrogen. I will keep it as X. Solve it out. How do we solve it? So nitrogen X into how many atoms? 1 plus hydrogen plus 1 into how many atoms? 3 is equal to neutral molecule 0. So X plus 3 is equal to 0. Therefore, X will be equal to what? It will be equal to -3. So nitrogen here it is -3. Take one more molecule of nitrogen only. Say aluminium nitride, ALN. Okay. So here how do we solve it? What is aluminium? I know it is a group 13 family member. Therefore, I have to find for nitrogen. So I will keep it as X. So what is the aluminium having charge? Aluminium has +3 charge. I should be knowing this. Lithium, sodium, potassium, rubidium, cesium +1. Beryllium, magnesium, calcium, barium, strontium +2. Boron, aluminium +3 always. Okay, then only I'll be able to solve it. Into how many aluminium atoms? 1. Plus nitrogen X into how many? 1. So it is 3 plus X is equal to 0. Entirely it is 0. X is equal to -3. So what is the charge on nitrogen? It is again -3. What if I give you the molecule N2H4? Solve it out. Let us see. I want to find for nitrogen. So I will keep it as X. Hydrogen is bonded to a non-metal, so it is always +1. Correct? That I should be knowing. So nitrogen is X into how many atoms of nitrogen? 2. Correct? So it is 2 atoms. Plus hydrogen is +1 into how many atoms of hydrogen? 4. Equal to what? 0. So it is 2x plus 4 equal to 0, or 2x equal to -4. Therefore x will be equal to what? -4 by 2 is -2. Therefore nitrogen is having what charge? -2. Understanding? Nitrogen has -2. Take it for one more molecule, HNO2. HNO2. You take one more molecule, say HNO3. Okay, fine. So I want to find for nitrogen. So I will keep it as X. Is that right? Solve it out. So hydrogen +1 into how many atoms? 1. Nitrogen X into how many atoms? 1. Plus oxygen -2 into how many atoms? 2. The whole equal to 0 because it is a neutral molecule. So 1 plus X minus 4, 2 to the 4 is equal to 0. So -4 plus 1 is -3. So X minus 3 equal to 0. Therefore, X is equal to what? X is equal to 3. So in HNO2, nitrogen is having +3 charge. Nitrogen is having +3 charge. HNO3 +1 hydrogen into 1 plus X into 1. Always write oxidation state in a bracket better. Parenthesis. -2 oxygen into 3 is equal to 0. So 1 plus X minus 6 is equal to 0. X minus 5 is equal to 0. Therefore, X gives what? It is +5. So here nitrogen has +5 state. Is that right? Now, if I give you like this, suppose I'll give you a molecule, say NH4 plus. NH4 plus. Okay. Or I will give you the molecule, say NO2 minus. That means what? It means there is charge. It is not a neutral molecule. It is a polyatomic ion. You are supposed to find for nitrogen. Done. So nitrogen, we will keep it as X. Okay. So solve it out. So X into 1 molecule atom plus hydrogen plus 1 into 4 is equal to what? It is not 0. What it is? It is +1. So solve. X plus 4 is equal to 1. X is equal to 1 minus 4. So X will be what? X will be -3. So here X is what? It is -3. Is that right? Okay. NO2 minus X into 1 mole atom of nitrogen plus oxygen is what? -2 into 2 atoms is equal to, what is the whole charge? -1. So X minus 4 equal to -1. X equal to what? -1 plus 4, it becomes 3. So here nitrogen is +3. NO2 minus. Getting how to solve? Okay, let me give you one more molecule. Let us proceed. Examples. H2S2O7. Do you know what it is called? It is fuming sulfuric acid. It is called as oleum. It is called what? Oleum. H2S2O7. So you have to find for sulfur. Okay. So let us do it. Fine. So hydrogen +1 oxidation state into 2 atoms plus sulfur X into 2 atoms plus oxygen -2 into 7 atoms. Overall charge is 0. Therefore, 2 plus 2x minus 14 equal to 0. Or 2x will be equal to what? 14 minus 2 is 12. So it becomes +12. X will be 6. So sulfur has got what charge? It has got +6 charge. Getting? Understanding? It has got +6 charge. Okay. Then next example. I'm taking almost all the examples what we are thinking of. Okay. Let me say I will give you Ca3T2, one molecule, then KH2PO2, then you have, let me take it here, BaH4P2O4. Then let us consider some of the ions. PO4 minus 3, then P2O7 minus 4, then we can take for CO3 minus 2, okay, then ClO3 minus or ClO4 minus. So let us take for all these items. Now here you need to find it for phosphorus. For phosphorus again, here also phosphorus, phosphorus, phosphorus. And in this case, you are going to find it for carbon. Here you are going to find it for ClO3 minus. So ClO3 minus, you are going to find it for Cl, here also for Cl. Okay, so let us do it. Calcium. So I will name all of them. Phosphorus is X here. Okay. Calcium, it is plus 2 into how many atoms? 3. Plus phosphorus X into 2 is equal to neutral molecule 0. 3 2s are 6 plus 2x equal to 0. So X will be equal to what? Minus 6 by 2. So what is minus 6 by 2? It is minus 3. So phosphorus has minus 3 here. You can verify it. Okay. So phosphorus has minus 3. Next one. KH2PO2. Okay. So phosphorus. Potassium is how much? Plus 1. Into how many? 1. Plus hydrogen plus 1 into 2. Plus phosphorus X into 1 molecule, 1 atom plus oxygen minus 2 into 2 is equal to 0. So 1 plus 2 plus X minus 4 is equal to 0. Minus 4 plus 3 is minus 1. So X will be equal to what? It will be plus 1. It will be plus 1. Yes or no? So minus 4 plus 3 is minus 1. X minus 1 is equal to 0. X is equal to plus 1. So oxygen, phosphorus here has what charge? It has got plus 1 charge. It has got plus 1 charge. Okay. Next, here phosphorus again, barium is plus 2 into 1 plus hydrogen is plus 1 into 4 atoms of hydrogen are there. Phosphorus is X into 2 plus oxygen is minus 2 into 4 is equal to 0. So 2 plus 4 plus 2x minus 8 is equal to 0. So 2 plus 4, 6 minus 8 is my 2x minus 2 equal to 0. So X will be equal to what? 2 by 2, it is 1. So plus 1 is the oxidation state. Plus 1 is the oxidation state for phosphorus. Is that right? Yes, got it. Okay, here phosphorus. So X into 1 plus minus 2 into 4 is equal to, what is the charge? Minus 3. So X minus 8 is equal to minus 3. So X is equal to 8 minus 3, that is equal to 4. So it is plus 4 on PO4. PO4 minus 3. Is that right? I'm sorry, it is plus 5. 8 minus 3 is 5. So it is plus 5. P2O7, X was phosphorus into 2 plus minus 2 into 7 is equal to minus 4. Minus 14. So 2x minus 14 equal to minus 4. Take minus 14 that side. 2x equal to minus 14 becomes plus 14. So it is 10. X is 5. So plus 5. P2O7. 4 minus is, what is the oxidation state of oxygen? Phosphorus. It is plus 5. Carbon, X into 1 atom plus oxygen minus 2 into 3 atoms is equal to minus 2. So X minus 6 is equal to minus 2. Therefore, what is X? It is plus 4. Correct? ClO3 minus. Chlorine is X into 1 chlorine atom plus oxygen is minus 2 into 3 oxygen atoms is equal to minus 1. ClO minus here 1 it is. Minus means 1, minus 1. So X minus 6 is equal to minus 1. So X is equal to what? It is 5. So chlorine is having plus 5 charge. Cl has plus 5 charge. Correct? Here similarly, X1 plus minus 2 into 4 is equal to minus 1. So 4 2s are 8. X 8 minus 1 is what? It is 7. So here chlorine has plus 7 charge. It has plus 7 charge. Is that right? So this is how we find the oxidation states. You can take it for carbon also. Carbon is also having different oxidation states. Oxygen you can take Na2O2, peroxide it is. Yes. So here you want to find it for oxygen. If you want to find it for oxygen, how do I write it? Plus 1 sodium into 2 plus oxygen I don't know into 2 is equal to 0 overall charge. So 2 plus 2x is equal to 0. So x is equal to what? Minus 2 by 2. It is minus 1. So oxygen has got what charge? In peroxides, it has got minus 1 charge. Minus 1. Is that right? Even we have fractional oxidation number also. Yeah. I can take you example, say KO2. Solve it out for oxygen. Let me see. I want to solve it out for oxygen. I will keep oxygen as X. Okay. So solve it out. Potassium plus 1 into 1 plus oxygen, I don't know, into 2 is equal to 0. So 1 plus 2x equal to 0. X will be equal to what? Minus 1 by 2. See, it is minus 1 by 2 oxygen. The charge on oxygen is minus 1 by 2. So this is how we calculate the charges. One more example. KMnO4, K2MnO4, MnO4 minus 2. Solve all of this. Okay, let us see. For Mn, for Mn, for Mn, we are going to solve. So potassium plus 1 into 1 plus MnX into 1 atom only plus oxygen minus 2 into 4 atoms is equal to 0. So 1 plus x minus 8 equal to 0. Minus 7 becomes plus 7. So x will be plus 7. K2 plus 1 into 2 plus x into 1 plus minus 2 into 4 is equal to 0. So 2 plus x minus 8 is equal to 0. Minus 6 becomes plus 6. Mn. See, what is the oxidation state? It is plus 6 plus 7. Manganese shows the highest oxidation state around plus 7. Okay. Mn again x into 1 plus oxygen minus 2 into 4 is equal to what? It is equal to minus 2. Therefore, x minus 8 is equal to minus 2. X is equal to what? 8 minus 2 is 6. So here also it is plus 6. MnO4 minus 2, it is plus 6. Is that right? So this is how we find the oxidation states. These are the rules to find the oxidation state. Fine. Now there are exceptional cases. Exceptional cases. So what are the exceptional cases? Exceptional cases of evaluation of oxidation numbers. There are type 1 molecules as sulfur in H2SO4, H2S2O8, and H2S2O8, chromium in CrO5. Okay, then we have type 2 molecules, we have type 3 molecules. Okay, let us see what are these exceptional cases. Fine. Okay. I'll take the better new slide. See, the rules describe whatever rules we have studied, they are useful for determination of oxidation number of a specific atom, okay, in simple molecules. But these rules fail in some of the cases, wherein the oxidation numbers are evaluated using the concepts of chemical bonding involved. So what is the first one they have said? They have said type 1 molecules. Type 1 molecules. So let us see those molecules and let us try to understand. In that, the first molecule given is, you need to find the oxidation state of sulfur in H2SO5. So in H2SO5, what is the oxidation state of sulfur? This is called per-monosulfuric acid. H2SO5, it is called per-monosulfuric acid, or it is also called Carrot's acid. Okay. Exceptional cases I am taking. Carrot's acid. By usual method, how we do? So this is X. So usual method I will write. Usual method. Plus 1 hydrogen into 2 plus X into 1 plus minus 2 into 5. The whole is equal to 0. Correct? So it is 2 plus X minus 10 equal to 0. And X will be equal to what? Minus 8. This becomes plus 8. So oxidation state of sulfur in Carrot's acid, it is plus 8. This is by usual method. But this cannot be true. It cannot be true because maximum number of oxidation state for sulfur, maximum oxidation state for sulfur is plus 6. It cannot exceed plus 6 because sulfur, why it cannot exceed plus 6 is because because sulfur has 6 valence electrons. And here how much it is showing? It is showing 8. Yes, in its valence shell, it is having 6 valence electrons. Therefore, maximum is +6. Here it is showing by usual method +8. So this exceptional value, it is due to the fact that 2 oxygen atoms, if you look at the structure of this Carros acid, it is sulfur central atom. It is bonded to 2 oxygen atoms through a double bond. One oxygen forms a peroxide linkage and another one is OH. So H2SO5. This is the structure. Yes. So this is due to the fact that 2 oxygen atoms you can see here in H2SO5 show peroxide linkage. So when they are showing peroxide linkage, evaluation of how do you do the evaluation? These two are showing peroxide linkage. For peroxide, oxygen is having so let me say for peroxide, oxidation number is what? It is -1. Yes, we have seen it. So oxygen oxidation number is -1. Therefore, you solve it out and see how much you get. So H2SO5, correct? Therefore, H2, it is +1 into 2 plus sulfur is X into 1. I will write it like this, plus. There are how many oxygens? Oxygen, there are 3 oxygens which are having -2 charge plus 2 oxygens with -1 charge. Understanding? 2 oxygens with these 2 oxygens are having -1 charge. This is having how much? -2 charge. Getting my point? Now solve it. So 2 plus X minus 6 minus 2 is equal to 0. -6 minus 2 is what? It is -8. -8 plus 2 is how much? X will be equal to 6. So oxidation state of sulfur in this is what? It is not a +8. Instead, it is +6. Understood? Similarly, take one more example. Okay, I will make a I'm sorry. So I'll make a distinction here. Second example is sulfur, oxidation state of sulfur in H2S2O8. Yes, this is called peroxydisulfuric acid, or it is also called as Marshall's salt. It is also called as Marshall's salt. Find the oxidation number by usual method. So it is +1 into 2 plus X into 2 plus -2 into 8 is equal to 0. So 2 plus 2x minus 16 is equal to 0. -16 plus 2 becomes -14. It becomes +14. So x is equal to 14 by 2 and that becomes 7. So sulfur oxidation state of sulfur is by usual method +7. Again, that is not possible. Look at the structure of sulfur. The structure of sulfur in a structure of H2S2O8, that is Marshall's salt, is sulfur double bonded to oxygen, oxygen, then sulfur, double bond O, and then OH is there. So let me write the oxidation states. This is +1, this is -2, this is -2, this is -2. I need to find sulfur X. This is what? Peroxy linkage. So oxygen will have -1 charge. Again, this is having -2, +1. Getting? Now you solve it out. So here I can solve usual method only you take. Hydrogen is +1, not to worry, into 2 hydrogen atoms, plus sulfur is X into 2 sulfur atoms, plus how many oxygens with -2? 1, 2, 3, 4, 5, 6. So with -2 there are 6 oxygens, plus with -1 there are 2 oxygens is equal to 0. Getting? So 2 plus 2x minus 12 minus 2 is equal to 0. This is -10. So 2x will be equal to what? -2, -12 minus 2 is -14. -14 plus 2, -12. -12 becomes +12. So x is equal to what? It is 6. So oxidation state of sulfur is here plus 6. It is not plus 7. Understood? So these are type 1 molecules. There is one more example also in that type 1 molecule. That molecule, what they have given is what? Chromium. Chromium in CrO5. Yes, immediately what we will do? We will try to solve it by usual method. So chromium is X into 1 plus oxygen is minus 2 into 5 equal to 0. So X minus 10 equal to 0. X is equal to what? Plus 10. See, is it plus 10 chromium? Impossible. This cannot be true, as maximum oxidation state for chromium cannot exceed plus 6. Yes, since chromium has only 5 electrons in 3d orbitals and 1 electron in 4s chromium. Outermost configuration is 4s1 3d5. So it is having how many? It cannot exceed this plus 6. Therefore, look at the linkage. It is due to the fact that chromium structure, if you see the structure of chromium, it is chromium is the central atom. It is bonded to oxygen atoms like this. So there are 4 oxygen atoms like this, which are showing linkage here, and 1 oxygen is double bonded. 1 oxygen is double bonded. So let us write the oxidation numbers here. This is what? This is peroxy linkage. This is also peroxy linkage. So minus 1, minus 1, minus 1, minus 1, and this is what? Minus 2. This is X. Now solve it out. Let us see. So chromium is X into 1 plus 4 oxygen atoms are having minus 1 charge because they have peroxy linkage into 4 plus 1 is having minus 2 is equal to 0. So X minus 4 minus 2 is equal to 0. Therefore, X is equal to what? It is equal to 6. So oxidation number of chromium is what? Chromium in CrO5, it is plus 6. It is plus 6. Okay. So this is type 1 molecules. Coming to the next one, that is type 2 molecules. What are these type 2 molecules? So in type 2 molecules, if they contain covalent or coordinate bond, what are the rules? For each covalent bond, dissimilar atoms, we know less electronegative is assigned plus 1 and more electronegative is assigned plus 2. Okay. In case of coordinate bond, how do we do the between similar or dissimilar atoms? Donor atom, if it is less electronegative than acceptor, oxidation number of plus 2 is given to donor atom and oxidation number of minus 2 is given to acceptor atom. Conversely, if donor atom is more electronegative than acceptor atom, the contribution of the coordinate bond is neglected. Contribution of coordinate bond is neglected. We will not consider it. Yes. For example, if you want to find oxidation number of carbon in HCN. In HCN, if you see, it is HC bond N. Or we write it as HN bond C. Here is the coordinate bond. So evaluation of oxidation number of carbon cannot be made directly by using rules which are given standardly. Yes, because no standard rule exists for oxidation number of nitrogen and carbon here. Yes, so how do we calculate? So contribution of coordinate bond, if I take example of HN double bond, coordinate bond in this direction, see. So this is donor, this is acceptor, and donor is more electronegative. Correct? So how do we do it? For more electronegative nitrogen atom, which is donor, and less electronegative carbon atom, which is acceptor. Okay. So oxidation number of nitrogen remains minus 3. It remains minus 3 because it is having 3 bonds. One is coordinate. Okay. So plus 1 into 1 hydrogen atom plus minus 3 into 1 nitrogen atom plus X into 1 carbon atom is equal to 0. So 1 plus minus 4. So 1 minus 4 plus X equal to 0. So it is minus 3. Therefore, carbon will have minus 3. So minus 4, it is minus 3. Correct? So X minus 3 plus 1. So it is plus 2. So carbon will have what charge? Plus 2 charge. This is how we calculate. So this is for type 2 molecules. Now we have type 3 molecules. So what are these type 3 molecules? Exceptional cases, I'm saying. Questions will be frequently asked on exceptional cases only. Finding the oxidation state of sulfur in Na2S2O3. Na2S2O3. Usual method, how do we do? Sulfur, suppose. Okay. So plus 1 sodium into 2 plus sulfur is X into 2 plus oxygen is minus 2 into 3 is equal to 0. So 2 plus 2x minus 6 equal to 0. 4 plus 4x is 2. So x becomes 2. So sulfur is plus 2, we say. This is not acceptable as two sulfur atoms in Na2S2O3 cannot have same oxidation state. The reason is Na2S2O3 molecule, when it reacts with H2SO4, it will form Na2SO4 plus SO2 plus S plus H2O. Yes. So because when treated with sulfuric acid, one sulfur atom is precipitated and other is oxidized. So this is precipitated. So in this case, oxidation number of sulfur is evaluated from concepts of chemical bonding. So chemical structure, if you write for Na2S2O3, it can be written as, how do I write the chemical structure? I will write it as Na plus, then I have here O minus, then S, one is coordinately bonded to sulfur, sorry, another sulfur here, and here I have double bond O, and here it is O minus, again Na plus. This is the structure. When you go with this structure, try to calculate the oxidation number. There are Na plus plus 1, 2 Na atoms are there, plus oxygen having minus 1 charge, right? So you can see there minus 2 charge. This will have minus 2 only. Fine. I've written negative charge. That's it. Into how many? This is also having minus 2. So there are 3. Plus X for sulfur into 1 plus coordinately bonded. This I'm going to find X. This is coordinately bonded means what? It will have minus 2 always. We have discussed. Into 1. That is equal to 0. So 2 minus 6 plus X minus 2 equal to 0. So 2 plus 6 minus 8 minus 6. So X will be equal to what? It will be equal to plus 6. It will be equal to plus 6. So in this case, it is not 2. It is equal to plus 6. Getting? So these are all what? These are the exceptional cases. Similar exceptional case we can also find in finding the oxidation number of chlorine in CaOCl2. Similarly, we can find it in nitrogen in NH4NO2, NO3. Then we have iron in Fe3O4. All these are what? These are all exceptional cases. And you have one more, sulfur in sodium tetrathionate. Sodium tetrathionate is Na2S4O6. Similar molecule comes here. We write it as Na plus O minus. Sulfur double bonded to oxygen, double bonded to oxygen, SS linkage. Then we have sulfur double bonded to oxygen, double bonded to oxygen, O minus, Na plus. This is the structure for sodium tetrathionate. Therefore, it will change. It will change. These are some of the exceptional cases. These are some of the exceptional cases. Hope you have followed with all of them. So rules for writing, then different examples involved here. After considered all the examples, here we have seen examples for finding nitrogen, oxidation state, whether it is a molecule or it is an ion. Then we have seen it for sulfur, for phosphorus we have seen, for carbon we have seen, for chlorine we have seen. Then we have seen it for oxygen. Then Mn, please remember, it shows the highest oxidation state up to 7. Even one of the member of the same group only, same block, it is osmium. It shows the highest oxidation state of plus 8. Then we have exceptions, type 1 molecules. because of the structure. Peroxy linkage is there, so oxidation state differs. We have type 2 molecules, wherein because of the bonding, coordinate bonding, there is difference in the oxidation state, and type 3 molecules. Type 3 molecules. Hope you have understood it. Okay, fine. So for calculation of oxidation number, all these rules have to be followed. And I hope you have followed with the exceptional cases also. Fractional oxidation number, as we have discussed for KO2, it is minus 1.1 by 2, right? Elements as such do not have any fractional oxidation number. When the same element are involved in different bonding in the species, their actual oxidation states are whole numbers, but an average of these are fractional. So C3O2, if you take, this is the structure. So average oxidation state of carbon atoms will be +2, 0. Yes, here it is 0 by 3. It is 4 by 3. So fractional oxidation number of a particular element can be calculated only if we know about the structure of the compound or in which it is present. Auto-oxidation. What do we mean by auto-oxidation? Okay. See, if you take example of turpentine and example of numerous, say, olefinic compounds, we call them as olefins. Do you know what are olefins? Olefinic compounds, they are nothing but having double bonds. Such compounds are called olefinic compounds. So turpentine, olefinic compounds, all they contain, yes. Or you take phosphorus compounds, or you take certain metals like zinc, lead, you take these metals. Okay, what happens here is they can absorb oxygen from air in presence of water. Yes, they can absorb oxygen from the air in presence of water. So when they absorb oxygen, water gets oxidized too, because, okay, I will show it here. So when they absorb oxygen from air in presence of water, water gets oxidized to H2O2. Okay, so this phenomenon of formation of H2O2 by oxidation of H2O is known as auto-oxidation. So it is happening on its own, right, in the atmosphere. Therefore, I don't call it as a process. I call it as phenomenon. So phenomenon of formation of H2O2, hydrogen peroxide, by oxidation of water is known as what? Auto-oxidation. It is known as auto-oxidation. Yes, so these substances, what I said, these substances which can activate oxygen. So what they will do? They will activate oxygen, and therefore those substances are called activators. What they are called? Activators they are called. Okay, so activator is supposed to first combine with oxygen. So activator first combines with oxygen, forms an addition compound which acts as an auto-oxidizer. So it will form auto-oxidizer. Yes, and reacts with water or some other acceptor so as to get oxidized later. So I can show you with an example. I said lead, so let us take example of lead only. Okay, so lead Pb plus O2. So what is Pb here? Pb is activator. So it will combine with O2 and forms what? It forms PbO. Okay, what is PbO? Auto-oxidizer. Fine. So this PbO, PbO2, it is formed. Okay, so it will then react with water. Auto-oxidizer will react with water and form what? And form PbO, lead oxide, plus H2O2. So is it formed? So these compounds react with oxygen in air in presence of water and form hydrogen peroxide. This reaction is called what? Auto-oxidation. It is called auto-oxidation. Yes. So auto-oxidation means certain compounds react with oxygen which is present in air in presence of water and form hydrogen peroxide Yes, and this process of formation of, or you can say, phenomenon of formation of H2O2 by oxidation of H2O is called auto-oxidation, occurs on its own. So what is the process occurring there? Activators, turpentine, olefinic compounds, metals such as zinc, lead, all these act as activators. They will first combine with oxygen, form auto-oxidizer. The auto-oxidizer then combines with water and forms hydrogen peroxide. Hydrogen peroxide. So this phenomenon is called what? It is called auto-oxidation. Auto-oxidation. I may give you one more example for explaining you auto-oxidation. Yeah. Let us take olefinic compound. Let me say double bonded compound. So I will take general double bond CHI. Okay. So it will first combine with what? O2. So what is this? This is what? This is activator. So when it is combining with O2, it will form what? It will form auto-oxidizer. Fine. Okay. So it will form auto-oxidizer. And the auto-oxidizer formed is RCH. Here oxygen, oxygen, CHI. This is the auto-oxidizer formed. This auto-oxidizer RCH, oxygen, CH, oxygen linkage, then R, it will combine with H2O and form what? It will form RCH, double bond CHR plus H2O2. H2O2. So hydrogen peroxide is formed. This hydrogen peroxide, yes, so turpentine or this unsaturated compound which acts as activator are supposed to take up oxygen molecule at the double bond position, okay, to form unstable peroxide. This unstable peroxide, what you call it as auto-oxidizer, it is also called mole oxide. It is unstable. Then what it will do? Which then gives up water molecule. It gives out oxygen on combining with water or any other acceptor and gives us H2O2. So evolution of iodine from Ki, potassium iodide, when treated with H2O2 can be confirmed with star solution which turns blue. So here what it forms? It forms KOH plus I2 gas will be evolved. This is what you say. If you want to confirm that it is H2O2, this is the confirmatory test. So what does it helps us? Auto-oxidation concept, it helps us to explain the phenomenon of induced oxidation. Induced oxidation. So oxidation is induced into the atmosphere. Yeah. So this is regarding auto-oxidation. Auto-oxidation. Is that clear? Okay, fine. Balancing oxidation reduction reaction. How to balance the oxidation reduction reaction. Okay, before that, different types of redox reactions. First, we will go through this. These are very simple, and then we will see balancing the redox reactions. Decomposition reaction, combination reaction, displacement reaction, and disproportionation reaction. Decomposition reaction. So what do we mean by decomposition reaction? This type of reaction involves the breakdown of a compound into different compounds. Decomposition, it is breakdown. Yeah, and decomposition reactions are what? They are endothermic. They will use energy. So examples are NaH gives 2Na plus H2. So breaking down. Okay. H2O breaks down to, and see this H2O breaking decomposition of water is not that easy. Okay. We need to use here electric, water breaks only in presence of electric arc, electrolysis of water I call it as. Gives H2O2. Na2CO3 breaks to give Na2O plus CO2. Okay. All the above reactions result in a breaking down of smaller chemical compounds in this form. Okay. But there are special case that confirms that all decomposition reactions are not redox reactions. What is happening? It is getting reduced. See, NaH, there is removal of hydrogen. So NaH is getting oxidized. Correct? Or H is becoming H2. It is getting reduced. So there is a redox reaction involved. Yes or no? H2O is becoming H2, removal of oxygen. So it is oxidation. Or O is becoming O2. So here O charge is what? -2. It is becoming 0. So it is decrease in the oxidation number, reduction. Yes or no? So here oxidation, I'm sorry. Yes or no? So oxidation, reduction both are taking place. Here also Na2CO3 is becoming NaO. Na2CO3 is becoming NaO. So carbonate has -2 charge. It is becoming carbon dioxide 0. So both oxidation and reduction are taking place. But not all decomposition reactions are redox. For example, calcium carbonate. If you see there is no such thing taking place. Okay. So they are all the decomposition reactions cannot be redox reactions. Next one, combination reaction. So what do we mean by combination reaction? Combination, combining. So these reactions are opposite of decomposition and reaction and hence involve combination of two compounds to form a single compound in the form A plus B giving AB. H2 plus Cl2 gives what? It gives HCl. So these are two different reactions. Okay, students? So two different reactions. So H2 plus Cl2 gives HCl. So two compounds are combining, two molecules are combining to form one compound, single compound. C plus O2 gives CO2. Fe plus O2 gives Fe2O3. It gives Fe3O4. Yes. So these are what? Combination reactions. H2 is becoming HCl. So hydrogen is removed, oxidation. Cl2 is becoming HCl. Hydrogen is added, reduction. Understanding. So these are all what? Combination reactions. Okay, which involve redox reactions. Displacement reactions. In this kind of reaction, an atom or ion in a compound is replaced by an atom or ion of another element. So how do we represent it? X plus YZ gives XZ plus Y. Y comes out. Further displacements are categorized as metal displacement reactions, metal non-displacement reactions. So displacement means what? There is displacement of some atom or ion into another. Understanding. So if you want, you can consider an example here, like say sodium plus, let us take, okay, we have to be very specific when we are taking the elements. So I will take Fe plus CuSO4. Yes, what happens here? There is displacement. Cu comes out, we get FeSO4. Correct? I can we view this equation reaction as CuSO4 is blue in color. When reaction occurs, it turns green due to formation of FeSO4. But reverse of this reaction is not possible, students. Taking Cu plus FeSO4, expecting to get CuSO4 plus Fe. This is not possible. The reason is, for displacement also there is a condition. Okay, let me write the condition. A more reactive element can displace a less reactive element from its solution. And this is based on, displacement reaction is based on reactivity series of metals. Reactivity series. Yes, in the beginning you have lithium, sodium, highly reactive metals. At the bottom, as you go, you have, for metal displacement I'm saying, at the bottom you have copper, then you have gold, silver, mercury, platinum and all. Hydrogen comes in between. Above all are more reactive, below are less reactive. That reactivity series must be known. So a more reactive element can replace a less reactive element from its solution. So iron is more reactive than copper. Therefore, iron has displaced copper from its solution. Whereas copper is less reactive than iron, therefore it cannot displace iron from its solution. Therefore, you cannot expect a green solution turning blue. Not possible, because reaction itself does not occur. So what is the condition? Very important condition. A more reactive element displaces a less reactive, can displace a less reactive element from its solution. Otherwise, it is not possible. And this is based on what? It is based on reactivity series. It is based on reactivity series. Is that clear? So reactivity series must be known. Okay. So in that we have two types: metal displacement reaction, metal non-displacement reaction. Metal displacement and non-displacement reactions. So in this type of reaction, a metal present in a compound is displaced by another metal. These types of reactions find application in metallurgical processes where pure metals are obtained from their ores. So obtaining pure metals from their ores, you call it as metallurgy process. Okay, so see the equation. CuSO4 plus Zn gives Cu plus ZnSO4. This is possible only because zinc is more reactive than copper. If you would have taken ZnSO4 plus Cu, there would be no reaction because copper is less reactive than zinc. It will not displace zinc from its solution. Is that clear? So this is about metal displacement reaction. In a non-metal displacement reaction, we can find a hydrogen displacement and sometimes rarely occurring reactions involving oxygen displacement. So only non-metal displacement reactions are called evolution. Always there is evolution of hydrogen. There will be evolution of hydrogen. Non-metal displacement reactions. There will be evolution of hydrogen. Like for example, when you treat any metal with acid, so this contains non-metal, right? What do you get? You get Na2SO4 plus evolution of hydrogen gas. So there will be displacement of hydrogen gas. So it is non-metal displacement reaction wherein I took NaH2SO4. So SO4 came up with Na and H2 gases evolved. Next one, disproportionation reaction. The reaction in which single reactant is oxidized and reduced is known as disproportionation reaction. P4, find the oxidation state. Elemental oxidation, it is 0. Here, can you find it? Phosphorus. So nitrogen, sodium is +1, 1 atom. Hydrogen is +1, but 2 atoms, so +2. Phosphorus is X, plus oxygen is -2 into 2 is -4, equal to 0. So 2 minus 4 minus 2 is equal to +2. So phosphorus is +2 here. What about this? X plus 3 equal to 0. Here it is -3. So can you see here? Phosphorus in zero oxidation state, it is becoming +2 in NaH2PO2. Whereas phosphorus, which is in zero oxidation state, it is becoming -3 in pH3. So 0 to +2 means what? Increase in oxidation number. What is this? Increase in oxidation number is what? This is oxidation. Correct? Decrease in oxidation number is what? Is reduction. So a single reactant is getting oxidized as well as it is getting reduced. Such reactions are called what? Disproportionation reactions. They are called disproportionation reactions. I can give you a few more examples for disproportionation reaction. So let us take examples, try to understand. First one, I'll give you reaction, you just try to find out. H2O2 plus H2O2 gives H2O plus O2. Yes, okay. So this oxygen 0. Here it is -2. In H2O2, what it is? -1, -1. Is that right? Correct? Okay. So if you look here, observe, -1 is becoming -2. Oxygen only, -1. Two molecules, same, both are same, no? So a single molecule I can say. Or I will write this reaction like this also. I can write it like this also, don't get confused. H2O2 gives 2 molecules. I'll take it like this, that's it. So here it is hydrogen peroxide, therefore it is -1. So in this case, if you see -1, oxygen from -1, it is becoming oxygen -2. So -1 is becoming -2. Gain in oxidation number. So decrease in the oxidation number. So -1 is becoming -2. Decrease in the oxidation number. Therefore, what we call it as oxidation. Oxidation or no? Yes or no? Decrease in the oxidation number. So -1 is becoming -2 by gaining electrons. Therefore, it is reduction, right? Now, -1 is becoming 0. What does that mean? Loss of electrons. So it is what? Oxidation. So a single molecule is getting oxidized as well as getting reduced. Such reaction is called what? Redox reaction. Sorry, disproportionation redox reaction. One more example. KClO3 gives KClO4 plus KCl. Write the oxidation states. Let us see. In this case, what is the oxidation state of chlorine? This is +1, -2, -2, 3 into 3 is -6, -6, -5. This becomes +5. Correct? Okay. In KClO4, +1, -2, -8, -8 plus 1, -7, -7 becomes +7. Correct? Okay. Here it is K plus and it's -1. Is that right? So what can I say? From Cl +5, it is becoming +7. And here it is becoming -1. So what is happening? Cl from +5, it is becoming Cl +7. Loss of electrons, oxidation. Similarly, Cl +5, it is becoming Cl -1. +5, +4, +3, +2, +1, 0. It is gain of electrons. So it is reduction. So a single molecule is getting oxidized as well as getting reduced. Yes, this is called what? Disproportionation reaction. You can try it out at home for Cl2 plus NaOH gives NaCl plus NaClO3 plus H2O. You can try this for disproportionation, whether it is disproportionation or no. For you can try it for chlorine. Okay, so it is here 2 more different I'm getting. Try it out. I will explain it again, but you try it out for this. Yes, so I hope you have understood everything. In the next class, we will discuss balancing the oxidation reaction and then go for the multiple choice questions. Please practice the concepts. Thank you.